Hello everyone and welcome back. So in today's video what we are going to be doing is solving the 10th problem of educational DP contest. Now today's problem I would say not a great problem to learn dynamic programming because this problem actually requires you to know certain mathematical formulas or concepts in order to solve this problem. But I will cover all those concepts in this video so that you guys are able to solve this problem without facing any difficulty. So with that being said, I would also like you guys to subscribe to my channel and also hit that bell icon so that you guys get notification whenever I upload new content. So let's go on solving today's problem. Now today's problem name is Sushi, and as I told you, this problem requires certain mathematical concept which you need to know before solving this problem. So here you need to know something known as expected value, which is a concept in probability, and this is a website known as Khan Academy, and they have actually explained this concept pretty well here. So I will post the link in the description so that you guys can go and check that out. And if you don't understand, please comment in the comment section so that I will try to explain you. So let's see what expected value actually means. So given x random variable, this is a probability distribution. So if you see here, this x is a different value of random variable, and we have a associated probability with each random variable. Now, how we'll calculate expected value? So for calculating expected value, we just multiply this value of x with the probability, and we do this operation for all the value of h, and then ultimately we add all the value which we get, and that's the expected value of h. So what I mean by this is, let's see here. So here we have h and probability of h, so we multiply these and we get certain values, and then we add these value and we get the expected value. So the important thing here to notice is, for calculating expected value, we require probability of each random variable. So that's what is the main thing here. You need to know the probability of each value of x in order to calculate expected value. So if you have understood this, let's see what problem statement says. Now we are given n digit number from 1 to n, and on each this we have certain number of sushis, and the minimum value of sushi is 1 and the maximum value is 3. Now there is a guy named as Taro, and he will perform certain operation until each sushi in each plate get finished. So what is the operation which Taro will perform? So he will roll a dice, and this is not like a normal dice where we get the maximum number as 6. Here we can get the number from 1 to n, and by the way n here is number of this. So whenever you roll a dice, you will get the number from 1 to n, and when you get a number, what you have to do, you have to go to that number of this and then pick one of the sushi and eat it. And if there is no sushi on that dish, we don't have to do anything. So what we have to do here, we have to find the expected number of times we have to perform these operation in order to finish all the sushis in all plates. So that's what we have to do. Now let's see the constraints. So constraint here is the value of n can be maximum of 300. So 300 means we can have the maximum number of dishes at 300, and I have already told you the number of sushis in each plate can be maximum of 1 to 3. And let's see the input. So the first line represents the number of this, and the next line represents the number of sushis in each plate. So that's what it written here. Now sample input, if you see here, we have 3. That means we have 3 plates, and on each plate we have like 1 sushi. And for this sample input we have answer as 5.5, and we will see how we have arrived at this answer. So let's see how we'll solve this problem. Now as I have told you, there are n dishes number from 1 to n, and I have just taken a random example here. So if you see here for this one, all plate 1 we have 1 sushi, for plate 2 we have 3 sushis, and for plate 3 we have 2 sushis. So first thing that can come to your mind is why not create a DP state for each of the dishes from 1 to n. But if you do that, the number of dishes, if you see here, it's 300, and that will be actually a bad solution. I'm not saying that won't work, but it will require a lot of space. So that is actually a very bad solution. So what we can do here? So if you see here, we are not concerned with how many sushis are there in each plate. We are concerned that we have to finish all the sushis in each plate. So that's what we have to do. We have to finish each plates so that there is no sushi left in each plate. Now, for doing this, we are only concerned with how many plates are there which has one sushi, how many plates are there which has two sushi, and how many plates are there which had three sushi, because the maximum number of sushis in each plate can be three. So we will define the DP set accordingly. So if you see here, I represents the number of plates having one sushi, and J represents the number of plates having two sushi, and K here represents the number of plates having three sushi. So DP of I, J, K represents the expected value to reach to a state with I number of one sushi, J number of two sushi, and K number of three sushi. And let's recall what is the probability formula. So calculating probability of H is equal to H upon total number of output. And if we want to calculate the probability of I, and by the way, probability of I means the number of plates having only one sushi, so that will be equal to 1 upon total number of outcome, that is 1 upon I plus j plus k. Similarly, we will calculate for j, and j here represents the number of plates with two sushi, so that will be j upon 1 plus j plus k. And similarly, we will calculate for p of k, where k represents the number of plates with three sushis. So if you have understood this, let's see how we'll approach this problem. So if you see here, the minimum number of sushis in each plate will be at least one. So what will be the minimum operation which you will require to solve this problem? So the minimum operation will be n, and if you think about is why we are taking minimum operation as n, because we have at least one sushi in each plate, and we have to roll the dice at least n time, and it will be definitely more than that for most of the cases, because if you throw your dice n times, then for each plate we will reduce the sushi value by 1. So this will be 0, this will be 2, this will be 1. So this is the formula which we will be using for minimum operation. And why I have divided by I plus j plus k, because this is the probability. So n divided by total number of outcome, that is what I have listed here. So if you have understood this, let's try to see what we'll do next. So we have three options: either to choose a plate with only one sushi, or to choose a plate with two sushi, or to choose a plate with three sushi. So if you choose a plate with one sushi, that means you choose a plate I, then you will reduce the value of I by 1, and everything else will be same, that is j and k. So you won't decrease the value of j and k, and you are multiplying by pi because you need to calculate expected value, and I have told you for calculating expected value you have to multiply by probability. So this is for choosing a plate with only one sushi. For choosing a plate with two sushi, we'll use this formula. So for choosing a plate with two sushi, you will decrement the value of j by 1. So let's say I choose a plate with two sushis and I eat that sushi. So how many sushi will be left in that plate? That will be 1. So number of plates with having one sushi will increment to 1. So this will be dp of I plus 1, and I am multiplying by the probability of j. And similarly, we'll do for plates having 3 sushi. So if we choose the plate having 3 sushi, then we'll eat that sushi. Then we will be left with 2 sushi on that plate. So uh, we will do k minus 1. But since we are having only 2 sushi in the plate, then that means we'll increase the value of j by 1, and then ultimately we'll multiply by probability of k. So this is the formula which we will be using. So if you have understood this problem, let's try to code this solution out. So let me just open a custom test, and let me also zoom in little bit so that you guys are able to see. And on first line we have n, and the next line we have the value of each this. So let me just take this as input. So we have the value of n. Now we have to take the value of sushi in each plate. So for that we need an array, and let me just take this also as an input. Okay, let's see the value of each plate. These are integers, so we are good. So next thing is we have to calculate number of plates having one sushi, number of plates having two sushi, and number of plates having three sushi. So that's what will be the DP state. So let's calculate that as well. So for that, let's try to have a variable with one, twos, and threes. Initially, all the value will be 0. So we have to calculate the plates having only one sushi, and let me just iterate over the array. So if I is equal to 1, then we'll increment the value of 1, and similarly we'll do for other plates as well. So I forgot to write equal to here, and else we will increment the value of 3. We are done. So let's calculate the maximum number of plates having one sushi, two sushi, and three sushi. So maximum number of plates having one sushi will be equal to ones, twos, and threes. Why? Because if you see here, so imagine if you are having something like this. So we will have a plate having one sushi, but we can decrement a plate having three sushis as 1 by decrementing the value of 3 by 2, and similarly if we decrement the value of 2 by 1, it will be 1. So this will result into 1 comma 1 comma 1. So that's why I have done 1s plus 2s plus 3s. And similarly, what will be the maximum value of plates having 2 sushi? So for that, we can't use this value, we can use the value of 2s plus this value, because if we decrement the value of 3 by 1, that will be again 2, so this will be 3's. And for maximum value of plates having 3 sushi, that will be equal to 3's, because these are less value and there is no way we can make a plate having 3 sushi by decrementing these 2 and 1 value. So if you have understood this, let's try to write this down here. So maximum plates having 3 sushi, that will be just threes. Now next thing we have to use this DP formula, but before that we have to initialize all DP, and this DP will be 3 dimension. So let me do that as well. So DP will be something like n cross n cross n, and that's what I'm doing here. So let me just do it here. So I have a DP of n cross n cross n with value initialized as 0, and even if I try to print it, we should get some DP value. Let me just copy a sample input and show you whether we are getting a correct DP field. Yeah, so we have a DP with 3 dimension. So the next thing is to use this DP formula to calculate the expected value, and we'll start from K. So K will correspond to 3, J will correspond to 2, and I will correspond to 1. So let me just do that. So maximum value of K will be match 3. Similarly for J, so J here correspond to 2's. And since I have already taken K, so this will be minus K. And let me do for I as well. Because we have taken K and J, so we have to minus those number of plates, that is J minus K, and these are the maximum value of 1. So our loop will go till that. Now if we have the value of I plus j plus k as 0, then we have reached our answer, then we don't have to do anything. Okay, so next thing will be to fill the DP table. So this formula correspond to this first formula, which is for the minimum number of operation, and now I have to use these formulas as well. So let me do this. So before that, let me check if I is greater than 0, then I will fill this DP. So if we are choosing a plate having just one sushi, then it will be I minus 1, J will be same, K will be same, and we have to multiply by probability. So for that I have to multiply by I upon I plus J plus K. So if we are choosing a plate having two sushi, then the formula we will use is second one. So let me just copy this and change it here. So J here will decrement and I will increment, and I have explained you why we are doing this, and this will be multiplied by J. And by the way, why I am doing J divided by I plus J plus K, because we have to multiply by probability, that is Pj, and Pj is calculated by J upon I plus J plus K, and similarly we'll do for K as well. So if we choose a plate having 3 sushi, then it will be something like this will be K and this will be K minus 1, J will increment, and this will be same, and K upon I plus J plus K is the probability. So I think we are good. So if we try to print this, so we have to print the last value, and that will be stored in I J K, because this loop will stop here and the I J K will have the last value. So that's what we have to print, and let me just run it. So before that, let me just see whether we have written the correct formula. I think we are good. Let me just try to run it. We are getting 5.5. What was the answer? This was 5.5. Let me just copy one more sample input. I'm getting divide by 0 error. Let's see what I'm doing wrong. So I have done I plus j plus k is equal to 0. Then we continue. So this error we shouldn't get, because these have some integer value. Okay, so I have not used the bracket here because it might be dividing n by I, and I might be 0. So let me see whether this works. We are getting 3, and let's type all sample input 3. We are getting 4.5, and I think our answer is correct. Let me just run it for all the test cases. So I think it should be accepted. Let's see. So if you see we are getting AC, that means our answer is getting accepted. So that's all from my side, and if you like my video, please subscribe to my channel, and I'll see you in the next one.